Hey, Science 6. Just want to do a little bit of a demo here on something related to weather. And as you may or may not know, I'm a bit of a music person. And I actually do own a good old-fashioned vinyl record player and a small collection of vinyl records. And I'm not here to talk about music today, though. I'm here to talk about the effect of the Earth's rotation on weather systems. So I'm going to use the good old turntable here as a way to simulate the rotation of the Earth. So first let me pull off the records that's on there. What do we have here? Ooh, Boston's debut album featuring the song More Than a Feeling. Definitely a good one to have. Ask your parents whether or not this is a good one. That's a classic. But, so I have some paper. I'm going to reach over here and I'm just going to take a piece of paper, and so that it fits onto the turntable, I'm going to kind of turn it into a square. That was a bad square. Let me make a better square. Tear this off. That's off a little bit of a pattern there. There we go. That's a little better. So I'm going to put the paper onto the turntable so that I can take and rotate it just as the Earth would rotate. And hopefully what I can see then is simulate with a marker what would happen as air tried to move from the equator toward the pole. So I'm going to simulate the center pivot of the record player as the equator, and air trying to move toward the poles as I spin the record player. So I'm going to take and move the pen. The pen's going to move straight out while the paper turns beneath it, which is going to be the same as air trying to move straight from the equator where it's warm toward the poles where it's colder. So I'm going to spin the record player. My page was a little bit big. There we go. Spin the record player. Alright, I'm going to try this again because I went to do this and the marker I had was dead. Let's try it again. So, spin the record player. Draw a line out. So what happened when I drew that is it did not form a straight line. Notice that it is a curve. You kind of expect that from this. So what this means is that the arc is going this way. So that means that, let's say that this is the center of a low pressure system here in the middle. And I'll even take and darken this line a little bit so that it's easier for you to see. Trace the line. So if this is the center of a storm system and air is being pulled into it, because we know that low pressure tends to be bad weather, that means if air's moving toward it in the case of a low pressure system, then this entire storm system is going to have a tendency to want to rotate counterclockwise. So you're going to be spinning this direction, which is a counterclockwise rotation. If it's a high pressure system for fair weather and the air is going to move outward from the middle, so I'll put my arrowhead on the other end, what you would notice is that the air is going to rotate the other way as it moves away. It's going to spin clockwise. And that's a pattern that we see in weather systems here in the northern hemisphere with the apparent rotation of the Earth. Now I'll show you in class the differences in apparent rotations. I maybe can do that here right now, where I have this little coaster, and if I rotate it this way, you can see that looks like it's going clockwise, but if I keep it rotating the same and just turn it around to look at the other side, from the other pole, it looks like it's rotating counterclockwise, and this is true for the Earth. So you might be looking down from the North Pole and you see the Earth spinning one way, but then if you go down toward Antarctica and you look at it, it looks like it's spinning the other way. So if I take a piece of paper and put this one onto the turntable in the same way to the other, and I'm going to spin the turntable the other way, and I'm going to draw the line with that. So let's see what this looks like if I spin the turntable the other way. So notice now, the arc coming off went the other direction. So if I was moving outward from the center, I would actually be going in a counterclockwise rotation, and if I was moving inward, it would be clockwise. And this is how weather systems move in the southern hemisphere. Everything, all the weather systems tend to have their wind spin a different way. And it's not that, you know, the physics or the science is any different, it's just that the apparent rotation of the Earth is different from the other pole. This is why Boston's famous for the storms called nor'easters. As a storm system moves to the south of us, the winds wrapping around are going to want to come around from the northeast as the storm system passes by us, so they get the nickname nor'easter. And the reason why the winds are from the northeast and not from the southeast or southwest is because of the counterclockwise rotation of cyclones, of storm systems in the northern hemisphere. This effect is called the Coriolis Effect. So, you know, the Coriolis Effect essentially is the effect of the Earth's rotation on the motion of winds in the atmosphere. And no, despite what you may have heard, it does not affect the way that water spins in the toilet when you flush it. This is a scale, this is something that happens to affect things on a global scale and not on a bathroom scale. Get it? Bathroom scale? Never mind. See ya.